Life cycle assessment. What is life cycle assessment? Life cycle assessment, also referred to as life cycle analysis, is a methodology used to evaluate the environmental impact at every stage of a commercial product, process, or services life cycle. This assessment encompasses the entire life cycle, starting from the extraction and processing of raw materials, continuing through the product's manufacturing, distribution, and utilization phases, and concluding with the recycling or final disposal of its constituent materials. By considering all these stages, life cycle assessment provides a comprehensive understanding of the product's environmental footprint and aids in identifying areas where sustainability improvements can be made. A life cycle assessment study consists of four stages. Goal and scope define the extent of the product's life cycle that will be considered and the specific objectives the assessment aims to achieve. This step also outlines the criteria used for comparing different systems and specific time frames under consideration. During the inventory analysis step, a detailed description of material and energy flows within the product system is provided, with a particular focus on its interaction with the environment, including the consumption of raw materials and emission to the environment. This stage involves describing all significant processes and related energy and material flows in the system. The information gathered during the inventory analysis is used for impact assessment in the third step. This step involves detailing the indicator results for all impact categories. The significance of each impact category is evaluated through normalization and, if applicable, weigh. Mandatory elements required for an impact assessment include: 1. Selection of impact categories. 2. Assignment of inventory analysis sorry, assignment of inventory analysis results to impact categories. 3. Calculation of impact category indicator results. The tool for the reduction and assessment of chemical and other environmental impact is used for the selection of impact categories. This includes the following: global warming, acidification, eutrophication, ozone depletion, ecotoxicity, smog formation, human health, carcinogenics, fossil fuel use. The interpretation of a life cycle includes conducting a critical review, assessing data sensitivity, and presenting the results. Advantages of using the life cycle assessment methodology. By employing the life cycle assessment methodology, it becomes feasible to assess the potential environmental impacts of a product, process, or service across its entire life cycle. The life cycle methodology enables a twofold benefit. Firstly, it facilitates the comparison of two different alternatives, aiding in the selection of the least impactful solution. Secondly, it facilitates a comprehensive analysis of all phases within a production process, thereby identifying priority areas for intervention and guiding the implementation of actions to improve the identified critical issues. An LCA can serve as a foundation for companies to the environmental performance of a product to stakeholders. Some limitations of using the LCA method. The focus of the study is mainly on global or regional impact, highlighting the necessity for additional site-specific data. The LCA methodology raises other significant concerns, such as the utilization of diverse methodologies for assessing environmental impact, varying software and databases, and at times the analysis of outdated data. Conducting a life cycle assessment study necessitates proficient expertise in the stages of data collection, processing, and interpretation. Conventional LCA alone cannot determine the most cost-effective or top-performing product, process, or technology. To achieve a comprehensive sustainability analysis, LCA must be integrated with cost analysis, technical evaluation, and social metrics. Thank you for your audience.